Good afternoon. So today we're going to be talking about dilations, so scale factors. So the first thing you want to do is if you look at these triangles, how are they the same and how are they different? Okay, so these are very different from what we've done before this last week, and this week is when we were talking about triangles that are actually the same size. These are different sizes. They may look pretty close, but one's bigger than the other. Now, if we look over here, if you look at it, when I move the slider, it does make it a little bigger, but when it's at 1, it is actually the same size. So this is almost like if you went to a copy machine and you made a copy of a picture and you made it twice as big. So 200% the size of it, or 2.25% bigger, 225% bigger. It's still the same shape, but it's just a little bit bigger. This is called similar. This is similar. They are similar. They may be the same shape, they have the same angles, but their size is going to be different. It's called dilation. Now, what do you think is going to happen so what do you think happen if our number is bigger than 1? So our dilation is bigger than 1. Okay. And if it is bigger than 1, we see that the shape gets bigger than 1. Now, what do you think is going to happen if our dilation is less than 1? It is going to get smaller as we go through. And this is what dilation does. So we're going to find out a shape, and then we're going to figure out if I say its dilation is 1/2, how are we going to draw the new shape? So here we go. We have dilation. So we're going to have our first image, our pre-image. This is our original shape. This is our original shape. So we're going to graph it. So at 3, 8, this is J. At 10, 6, this is K. And L is 8, 2. And we can see this is a triangle. And you can hear the trains in the background. Sorry about that. So what we want to do is we want to make this one have a scale factor of 1/2. And since it is smaller than 1, we know it is going to get, we're going to get smaller. Now, one of the big things here is you will notice the letter has a little of apostrophe. This just means it's called a prime, and it means that we are making the next shape. It's not the original, it's a copy. So if it's 1 apostrophe, it's the first copy. If it's 2 apostrophes, it's the second copy, and so on. And what we're going to do is we're going to take this 1/2 and we're going to times it by each of our numbers. So we take 3 times 1/2, and it's going to be 3 over 2, or 1.5. Half of 8 is 4. Half of 10 is 5. Half of 6 is 3. Half of 8 is 4. Half of 2 is 1. And so when we draw our next shape, we're going to have J prime, and then 5, 3, K prime, and 4, 1 is L prime. You have to have the primes on there. And we can see it does get smaller. Now, our next one, so here we have our shape, or our points. So F is at -1, 1. G is at 1, 1. H is at 2, -1. And I is at -1, 1. So this time we're doing Well, a trapezoid. And so this is our original. So this time we're going to have a scale factor of 4. So with a scale factor of 4, or do you think it's going to be bigger or smaller? And it is going to be bigger. So we're going to multiply each number by 4. So -1 times 4. And we're doing it to each number, okay? Each number. So I'm taking my G numbers, the G points, multiplying each one by 4. So 1 times 4, -2 times 4, and then we're going to graph it. So at -4, 4, we can see that f prime is definitely bigger. Don't forget the apostrophe. And 8, -4. And then we can see our new shape is definitely 4 times as big. 4 times as big. Okay, so if we have our points here, here's our 4 points. So P, Q, R, and S. So P is 0, -4. Q is 8, -4. R is 8, -8. And S is 0, -8. If we're going to have a scale factor of 4, what will be the new images? What will be the new coordinates of our image? Okay. So if we're given the shape now, can we figure out what is the scale factor? And what we're going to do is take our new image, divide it by the original. Okay, so new divided by old will give us our scale factor. And so we have some examples. So here is our new over our old, just so we remember what we're supposed to do. And when we do this, we really only have to pick one letter. So here's our new. So it's 1, 2, 3. 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, 6. So this is our B prime. That's our new one. And our B, original B, is 2, 2, 4. So we're going to take our original, our new point, divided by our old point. And you can either take the x's or the y values. It doesn't matter. It's really going to give you the same point. And if you divide it, our scale factor is 1.5. That's our scale factor. Okay. Now if we do another one, so I'm just going to go to number 3. I'm going to do it, pick an easy one, okay? I'm going to take my new one. So E is going to be 0, 2. Sorry, E prime. E, the original, 2, 3, is 0, 5. We can't really change the zeros, so we have to take the y values this time. So we're going to take our new one over our old shape, and we can leave it as 2 over 5, or we can always divide it, and we get 0.4 is the scale factor. Okay. Now, I want you to figure out what this scale factor is. Here is the original. Here is the scale factor. So what is the scale factor? And I like to abbreviate it as this. What's the scale factor going to be? All right. So hopefully you review these before you go on to the lesson on Thursday.